Day 365 of doing a LeetCode problem every day until I get a job. That's right, y'all. We made it all the way to day 365. That means we've been doing a year of daily LeetCode problems, y'all. So if you've been keeping up with this channel this whole time, go ahead and give yourselves a round of applause and a pat on the back, y'all, because it's not easy to stay disciplined and stay consistent. But guess what? You did. Now, with that being said, y'all, today we have question number 1007, minimum domino rotations for equal row. The difficulty level is medium, but don't even worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. In a row of dominoes, tops I and bottoms I represent the top and bottom halves of the ith domino. A domino is a tile with two numbers from 1 to 6 on each half of the tile. We may rotate the ith domino so that the top of I and bottoms of I swap values. Return the minimum number of rotations so that all of the values in tops are the same or all of the values in bottoms are the same. If it cannot be done, return -1. All right, y'all. So I can understand how that may be a little bit difficult to understand just by reading the question. So let's go ahead and take a look at these examples to make sure we're doing this question correctly. So in example 1, we have the input tops equals an array of integers representing dominoes 2, 1, 2, 4, 2, and 2. Bottoms represents an array of integers representing dominoes 5, 2, 6, 2, 3, 2. The output is 2. Explanation says the first figure represents the dominoes as given by tops and bottoms before we do any rotations. If we rotate the second and fourth dominoes, we can make every value in the top row equal to 2 as indicated by the second figure. So as you can see here, all they're doing is, right, this is the original configuration right here. This is dominoes after the rotations. As you can see at the top, we have a 2, 1, 2, 4, 2, 2. So we have a lot of 2's at the top, but not all 2's. And in this case, we're going to make them all 2's by swapping the 2's down here, or the necessary 2's down here at the bottom, to make sure that the top has all 2's. So if we come down here and look at the dominoes after rotation, we can see that we have a 2 here, 2, 5 here. We don't have to swap anything. Here up top we have a 1, 2, meaning we have to swap these two so we can move the 2 up top and the 1 to the bottom. So that's what they did here. Boom, we swap these two. We swap these two right here. Then we come here, we have 2, 6, 2 up here, 6 at the bottom, that's fine. Then we come here, we have a 4 at top, 2 in the bottom. That means we need to swap this again. That's another swap. So now we've had 2 swaps. So now we have a 2 at the top and a 4 at the bottom after the swap. Then we have a 2 and a 3, right? That can stay the same. And we have a 2 and a 2. We don't have to swap the 2 and the 2. But the goal is to have all of the same numbers at the top or have all of the same numbers at the bottom. And in this case, with the minimum amount of swaps. So whichever one requires a minimum amount of swaps, that's the one we go for. And in this case, we have all of the values at the top. We swap them so that they all are equal to 2. And that took us 2 swaps to do. We had to swap this one right here, these two, the 1 and the 2, and we had to swap this right here, the 4 and the 2. So thus the output is 2 because those were 2 swaps that we had to do. Boom, we're just counting the number of swaps. So let's go ahead and take a look at example 2 where it's not possible to rotate the dominoes to make one row of equal value. So in this case, we have the input tops equals an array of integers represented the dominoes 3, 5, 1, 2, and 3. Bottom equals an array of integers representing dominoes 3, 6, 3, 3, and 4. Output is -1. Explanation: in this case, it is impossible to rotate the dominoes to make one row of values equal. So just to give you a visual representation, I'm gonna copy and paste these over here because they represent the dominoes anyway, so it will still be able to work, or I'll still be able to show you. Boom. So as you can see, we could swap, say we swap the 2 and the 3 right here, right? So say we're trying to make them all 3. So we swap this 2 and a 3, so now that's a 2. We swap this 1 and 3, so now this is a 3. Excuse me. But as you can see, this 5 and 6 will not allow us to create another 3 right here, right? We need the whole top row or the whole bottom row to all be the same. In this case, we were trying to make the whole top row all 3s, but that's not possible because we have this 5 and a 6 right here. And no matter how we swap it, this top row will not all be the same elements. So we're going to return a -1. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult to understand at all, so let's get started. First thing we're going to do is we are going to create a variable that's going to count the occurrences of each numbers at the top row, each numbers 1 through 6 at the top row. So for that, we could just declare a variable. And since we're going to count the occurrences, we could just call it count T for count top row. And we could set that equal to an array of integers. Come outside of it, we're going to open up the parentheses and initialize it with repeating :zeros, comma, count 7. Boom, because we're only doing numbers 1 through 6. Boom, then we're going to do the same thing for the bottom row. So really, we could just copy and paste this. And then we could just change this T to a B for bottom row. And then we need to do the same thing one more time. So we copy paste this again, declare a variable. We could just call this same. And this is going to count how many times the same number appears on both top and bottom, similar to right here in example 1 where we have a 2 on the top and a 2 on the bottom. This is going to count that, and we could just call that same. Boom. Now we need to traverse all dominoes to populate the count arrays. So for that, we come underneath this. We could say for I in tops, for I in 0 ... less than tops count. We're going to open up the bracket and we're going to say count T square bracket tops square bracket I. We're going to increment that by saying plus equals 1. Then, so that's going to increment the count of number on top. Then we need to increment the count of number on bottom. So we're going to say count B square bracket bottoms square bracket I. Same thing, come outside, plus equals 1. Boom. Now both sides of the domino are the same, then we're going to count in the same. So we're going to say, come right here and say if tops square bracket I equals bottoms square bracket I, meaning they're the same, then we increment same by saying same square bracket tops square bracket I, come outside plus, sorry y'all. My bad, y'all. Clean that up. Come outside plus equals 1. Boom. Now we need to try each possible domino from numbers 1 to 6 to see if it can fill an entire row. So for that, we are going to come right here and we're going to say for I in 1 ... 6. We're going to open up the brackets. And we need to check if the total number of this value from tops plus bottoms minus the same covers all of the dominoes. So we're going to say if count T square bracket I plus count B square bracket I minus same square bracket I equals tops dot count. We're going to open up the brackets and we need to return the minimum number of rotations needed, either to make the tops or the bottoms all of the same value. So we're going to say return min. That's going to get us the minimum number of rotations, and we're going to say count T square bracket I, comma, count B square bracket I. Then we're going to come outside of these parentheses and we're going to say minus same square bracket I. And then now all we need to do is if we go through all this and no number can fill the entire row, then we could just come right here and we could just say return -1. Now let's go ahead and give this a run, y'all. Make sure it's running properly before we submit it. Let's see. Ooh, it's going kind of slow, y'all. Is that my internet or is that the runtime? Oh, okay. So what's the error? What does it say? Expected separator. What we looking at, y'all? Oh, sorry, y'all. And I copied and pasted, so we gotta do this for all. It should be a colon after every count right here. Boom. So let's run it again. See if it works this time. And it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted after we submit it. Let's see. Oh, look at that, y'all. 0 milliseconds beats 100% of users with Swift. That's what I'm talking about. That's what I like to see. So with that being said, y'all, make sure you get one more look at the code. This the top part. This the bottom part. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.